Assalamu alaikum. Today on 26th December 2025, I'm starting lecture number 16 with the title Revision Lecture. Uh, and since we have already completed all of the course, we will try to revise some important concepts. So let us share me the screen first. Okay, students, I think now you can see my screen. So, in chapter 14, exercise 14.3, we learned how to perform partial derivatives for a multivariable uh, function. So, some of the students asked me to solve the question where we are to calculate partial derivative of f with respect to x of question number 12, that is f of xy is equals to tan inverse y upon x. So this question has two parts. In the first part, we need to find the derivative of f with respect to x, and in the second part, we need to find the derivative of f with respect to y. So let us open our camera first. Okay, so now you can see my camera. So first of all, differentiating with respect to x, we can say partial derivative of f with respect to x is equals to the partial derivative of x of the given multivariable function tan inverse of y upon x. Now to find this derivative, we must know a basic formula, that is d by dx of tan inverse of x is equals to 1 over 1 plus x squared. Now, keeping this formula in mind, what we can say that the partial derivative of f with respect to x is equals to 1 over 1 plus y upon x whole square. Since our x is y upon x, you can relate the given formula with our function. So tan inverse of x is 1 over 1 plus x square, and our x is tan inverse of y upon x. So the derivative of x is 1 over 1 plus x square, like I always say. But since it is not a simple x, so we need to multiply with its derivative. Okay, the derivative of x is 1 over 1 plus x square. But since it is not a simple x, rather it is y upon x, so we need to multiply with its derivative. Now in the next step, we will open the bracket in the denominator. And here, since we are differentiating with respect to x, so y is constant, so we will take y out of the differentiation, and we will be remain with del by del x of 1 over x. In the next step, we will take LCM in the denominator. So it will become x square plus y square upon x square multiply by, now the derivative of x power minus 1 is minus 1 times x power minus 2. Finally, we will basically uh, change this longer upon with the division sign. So it will become 1 divided by x square plus y square whole upon x square. Then this division sign will be changed with the multiplication sign. So it will become x square in the numerator over x square plus y square multiplied by minus x square y. X power minus 2y, sorry, x power minus 2y. Now this x power 2 and this x power minus 2 will make it x power 0. So it will become minus x power 0 y upon x square plus y square. And since x power 0 is 1, so finally it will become minus y upon x square plus y square. So that was a bit tricky question, but you can see that if you know the basic formula, that is what is the derivative of tan inverse of x. So you can easily calculate uh, a complex partial derivative like tan inverse of y upon x. Okay. So now if we want to solve the derivative of the same function f with respect to y, so what we will do, let me just write the question again. So it is d by dx of tan inverse of y upon x. And this time we need to find the derivative of this function with respect to y. So we will write differentiating with respect to y. So del f by del y is equals to del by del y of tan inverse y upon x. Now, since the derivative of tan inverse of y is 1 over 1 plus y square, so the derivative of tan inverse y upon x will become 1 over 1 plus y upon x whole square into the derivative of y upon x, because this y is not simple y, rather it is y upon x. Okay. Now in the next step, we will open the bracket in the denominator. So it will become 1 over 1 plus y square upon x square multiply by, now we will take 1 upon x common and it will become del by del y of y. Now we'll take LCM in the denominator, so it will become 1 over x square plus y square upon x square multiply by 1 upon x times 1, because the derivative of y with respect to y is 1. Now finally it will become x square upon x square plus y square multiply by 1 upon x. So this x will be simplified with this x, and hence we will be left with x over x square plus y square. So you can see that again, if we know the basic formula of tan inverse of x, then finding the derivative of this function is not a very big deal. So students, I hope now you understand how to differentiate tan inverse y upon x with respect to x and with respect to y. Now coming to another question, which was basically asked by some Students, uh, let me just open the book. Yes. Now, another interesting question was question number 20, where you can see that we are to find the partial derivative of f with respect to x and y. And this time we have a complex logarithmic function with us. That is, we are to differentiate log base y of x. Okay. So what we will do to solve this question? Uh, in solving this question, we need to apply uh, a property of log that is known as the change of base property. So let me write this question. F of x, y is given as log base y of x. Okay. Now, if we are to differentiate this function, so what we will do, first of all, we will change the log base of this log. Currently, it is log base y of x. So if we are to differentiate it with respect to x, so first of all, we will convert this base into ln. So we will write log base y of x is equals to ln of x divided by ln of y. So now f of xy is equals to ln of x over ln of y. So now the base of this function f is not y anymore, rather it is e, that is the exponential or the natural log. So e is basically the base of this function now. Now we need to differentiate it with respect to x. So we will write differentiating with respect to x. So it will become del f by del x is equals to del by del x of ln of x divided by ln of y. Now, since we are differentiating with respect to x, so in partial differentiation, if you are differentiating with respect to x, then this 1 upon ln of y is constant for this differentiation. So we will bring this 1 upon ln of y outside the differentiation, and now it will become partial derivative of x with respect to x of ln of x. Okay. Now del f upon del x is equals to 1 upon ln of y. Now the derivative of ln of x is 1 over x. So hence the final answer will become del f by del x equals to 1 upon x ln of y. Okay. Now coming to the second part of this question. If again f is equals to ln of x upon ln of y, and we are to differentiate it with respect to y, so we will write del f by del y is equals to del by del y of ln of x over ln of y. Again, since we are differentiating with respect to y, so for this differentiation, ln of x is constant. So we will bring this ln of x outside of the differentiation, and it will become del by del y of 1 upon ln of y. Now, what is 1 upon ln of y? It can be written as ln of y whole power negative 1. And we all know that whenever we are performing differentiation, then first of all, we will differentiate with respect to power. So since it is y power minus 1, so we will differentiate it like minus 1 times y power minus 1 minus 1. Now I am saying ln of y as y because I am treating it as a y. So y power minus 1 is equals the derivative of y power minus 1 is minus 1 times y power minus 1 minus 1. But since it is not a simple y, rather it is ln of y, so we need to multiply with its derivative. We can again revise this thing. Derivative of y power minus 1 is minus 1 times y power minus 1 minus 1. But since it is not a simple y, rather it is ln of y, so we are to multiply with its derivative. That is the derivative of ln of y. Now, ln of x into minus 1 is basically minus ln of x into ln of y power minus 2. And the derivative of ln of y is 1 upon y. So finally, we can write it like minus ln of x upon y into ln of y power 2 in the denominator. So you can see that finding the derivative of this complex logarithmic function was not a very big deal if you know this change of base property. It is extremely important property. If you are to differentiate log base y of x, then this log base y of x can be written as ln of x upon ln of y. And hence, what we did, we basically separated x and y terms. So this thing made uh, it easier for us to calculate the derivative of the given function. So students, these were some problems that student asked me to solve. So I hope everything is covered and we practiced a lot of exercise problem in our course, since calculus and analytical geometry is a demanding course, and you all know that I always try to solve as much questions for my student as possible in the class. So I hope that you will perform good in your final term exam, and inshallah will meet you in the final with the final term result, and I hope that you will perform good in this course. This is your first semester, so my sincere advice to you people will be that you should work hard, you will try your level best to achieve good grades, because if you get good grades in your first semester, you will become stable in this university. So it will be easier for you to basically excel in your university life. And obviously, if you are getting good grades, then there are some extracurricular activities that are extremely important for the grooming of the students. So students could benefit themselves from those activities only if and only they are performing good in their academic activities. So my all of my prayers are with you, and inshallah will meet you with the final grade. Till then, take care and Allah Hafiz. If you want, you can ask any question. Okay, no questions. So inshallah will meet you with the final result. Thank you.